Kia ora koutou. This is for students who are working from home today, so happy St Patrick's Day. Here are 6 questions that I've pulled out of exercises 5.5, 6 and 7 of the old Delta book. So what we're looking at today are compound angles and some more trig identities. These are the 2 identities questions, those first 2 there. And then we're going to do a couple of expansions using the compound angle formula for tan. And lastly, we're going to look at some really cool questions where we're working with exact values. So this is probably going to be about a 15-minute video. Just skip through to the bits that you need. Make sure you have a crack at doing the questions first before I do them. All right, so let's start off with these 2 identities, which are both going to use the Pythagoras stuff. So starting out with the first one, we need to show that sine squared theta cot squared theta plus sine squared theta is equal to 1. So when we set up an identities proof, you'll see this over and over again for the next 6 weeks or so. We start on one side and we work our way towards the other side. So I'm going to start here with the left-hand side, and I'm always keeping an eye on where I'm trying to get to, which is the result that this equals 1. So we start by just writing out the left-hand side. And then I can see here that I can factorise out the sine squared theta. So sine squared theta into cot squared theta. Now I'll write that out straight away as cos squared theta over sine squared theta plus 1. Right, now pulling out, getting a common denominator of sine squared theta gives me, in here, cos squared theta plus sine squared theta. And we know that that equals sine squared theta over sine squared theta, because this is equal to 1. So the whole thing is equal to 1, which is the right-hand side as required. Okay, next question. Similar, again, uses one of the Pythagoras things. So I'm going to prove this. I'm going to start on the left and work my way towards 2 cosec theta. Okay, so left-hand side, tan theta over sec theta minus 1 plus tan theta over sec theta plus 1. The first thing I'm going to do when I've got 2 separate fractions is I'm going to get a common denominator. So my common denominator here, using difference of 2 squares, will be sec squared theta minus 1. In fact, I'm going to do an extra line. Because I'm doing a proof, I'm going to show that. All right, so on my first line here, all I'm going to do is combine this. So you really need to be careful when you're doing a proof not to skip out steps, because your goal is to step the reader through your thinking so that they can basically, without too much work, see how you got from one line to the next. And that's a kind of common mistake that confident students sometimes make with level 3 trig, is they think, oh yeah, it's really obvious, I can just jump a couple of lines. So that doesn't go too well. So here's what I'm doing here. I've got my common denominator and I'm doing my multiplying in the bits, right? So this tan theta is getting multiplied by this, and this tan theta is getting multiplied by this. Next, I'm going to expand. So in the denominator, I've got sec squared theta minus 1, and in the numerator I've got tan theta sec theta. I've got 2 of those plus tan theta minus tan theta. That gives me 2 tan theta sec theta over tan squared theta plus 1 minus 1. And in here, what I'm using is the Pythagoras result for sec squared theta. So I'm just going to write out the side, since sec squared theta is equal to 1 plus tan squared theta. Now, obviously, we could have derived that all the way back from sine squared plus cosine squared equals 1, but I think it's acceptable to use that identity here. Right, now what have I got left? Well, we're just about there. We've got 2 tan theta sec theta over tan squared theta, which is 2 sec theta over tan theta. But I want to be getting down to what? What did we need to get to? I think it was, we need to get to 2 cosec theta. All I have to do now is just write in my definition. So 2 times 1 over cos theta divided by sine theta over cos theta, which is 2 over cos theta times cos theta over sine theta. They simplify away, which finally leaves me with 2 cosec theta, which is the right-hand side as required. And you can see I'm already up to 5.5 minutes and I haven't even got into the core questions yet. Right? So those two were just some identities out of 5.5. If you focus, you will find that exercise quite fast to do. Right, let's look at the 5.6 ones that I've picked out. Okay, so in here, what this is really good for giving you practice at is actually using the compound angles that you've just seen. So the two tan ones, tan of A plus B is equal to tan A plus tan B over 1 minus tan A tan B. Okay, and the one for the difference, tan of A minus B, is equal to tan A minus tan B over 1 plus tan A tan B. So in class, the one that we proved out of all of these was we proved cos of A minus B. And then from there, we got a couple of the others. I haven't done a proof in class of the two tan ones, but you know, you can. It's not that bad. And I think it's in the back of Delta if you want to have a go at that. So what we're going to do now is we're just going to use these. So instead of B, we're going to have 45 degrees. And instead of here, we're going to have negative B. But it turns out that this one is going to need a little bit more thinking because the tan graph has asymptotes. And one of the asymptotes is at 3 pi on 2. So that part of the question we're going to take a little bit more slowly. But this first one is pretty fast. So moving over here, tan of A plus 45 degrees is equal to tan A plus tan of 45 degrees over 1 minus tan A tan 45 degrees. And we know that that is just a 1, 1 root 2 triangle. So that equals tan A plus 1 over 1 minus tan A times 1, which cleans up to be 1 plus tan A over 1 minus tan A. So that's that first one done. Okay, so now I'm going to wash back to the second one. Now this is going to be a little bit slower, so just be patient. I'll try not to make it too boring. We can start off, when we look at this next one, what this is asking us is to find an expression for when we take, when we do a translation. Okay, so we've got tan of an angle minus 270 degrees, right? So tan of an angle minus 3 pi on 2. In other words, if I had A is equal to, I'm trying to pick an easy number, if A is equal to 80 degrees, not 90 degrees, 80 degrees, we can find tan of A. But what we want to find is a nice expression for tan of 80 minus 270 degrees, right? Which is tan of negative 210 degrees. That's not right. Can't do maths, right? Tan of negative 190 degrees. And there's no problem with finding the tan of negative 190 degrees. It's going to be defined. The only places that the tan graph, or the tan function, is not defined is at these asymptotes. So at 90, 270, and so on. But because tan of 270 is not defined, if I just try doing this, where's it gone? If I just try doing my tan formula for the expansion, I'm going to run into trouble. So I'm going to start it out that way because I bet that's how most of you started it out. And I'm going to show you what we have to do when it goes bad. So tan of A minus 3 pi on 2. So just doing our usual tan A minus B expansion. This is what I'm going to get, equals tan A minus tan of 3 pi on 2 divided by 1 plus tan A tan of 3 pi on 2. So you can see we've got trouble because that's not defined and that's not defined. But we just saw that it should usually be possible to take 3 pi on 2 off an angle and find the tan. So what we're going to do to simplify this one is we're going to go back one step further and go, well, hang on, sine of an angle divided by cos of an angle is what tan of x is. And that is going to get us out of this hole. So let's see how we can do it. Well, tan of a minus 3 pi on 2 is equal to sine of a minus 3 pi on 2 over cosine of a minus 3 pi on 2. And we know how to do both of the sine and the cosine expansion. So now you're seeing why I picked this question for this video. So sine a times cos of 3 pi on 2 minus cos of a times sine of 3 pi on 2 divided by cos of a, cos of 3 pi on 2 plus sine of a, sine of 3 pi on 2. Right, so that's coming from the formula for cos of a plus b, for cos of a minus b and sine of a minus b, which was done earlier in the exercise. Just quickly sketching either my trig graphs or my unit circle graph. There's the cosine graph. And the cosine of 3 pi on 2, there's 90, 180, is here. And the sine graph, the cosine is going to be, the sine of 270 is going to be here. So it'll be at -1. The other way that we can see that is if we draw our unit circle and we just think about cosine of an angle is defined as x over r. So when I've got my angle of 270 and I'm around here, you can see that the x component is going to be 0 and the y component is going to be -1, right? And so that fits exactly, this picture fits exactly with this picture. Right, you can see that the cosine of the angle is here. If you're still having trouble thinking about the unit circle stuff with the graphs, then it's probably time that we sat down and had a look at that. So if you're in my class watching and you're not getting how those two things link up, please send me an email and we can do a Google Meet. Anyway, back to this question. What I've gotten here now is equal to sine A times cos of 3 pi on 2, which is 0, minus cos A times -1 over cos A times 0 plus sine A times -1, which gives me cosine of A divided by negative sine of A, which equals negative cot A. So where we've got to with this question is to say that if we take 3 pi on 2 off an angle, then its tan is equal to negative the cotangent of that angle. And that obviously is at values where it's defined. Okay, this is 13.5 minutes already. So what I'm going to do is do a second video, I think, with these last ones out of 5.7. Okay, so part 2 of this coming up in a couple of minutes. I'll just upload this one first. I wonder if anyone's got to the end of this video. I bet you haven't. Last time I said that, no one's claimed the chocolate fish yet. So let me know if you're still here and watching, and I will provide some form of chocolate.